arithmetic and geometric series. A series is the sum of the terms in a sequence. So we use the notation S subscript n to indicate the sum of the first n terms in a sequence. For example, for the sequence 1, 4, 9, 16, 25, S subscript 3 would just be the sum of those first three terms, which will give us 14. An arithmetic series is the sum of the terms of an arithmetic sequence. So these are two formulas that we have here. They're also in your IB formula book. Okay. This is the sum of your nth term. This is your term number. U subscript 1 is your first term. N is the same as before, your term number. And D is the constant difference. Here you have the sum of the nth term is your term number divided by 2 times the first term plus the nth term. So our first example is we're going to find the sum of the first 40 terms of the following sequence. So first 40 and sum tells me that I'm looking for S subscript 40. And I also know a couple things from my terms here. I know that my first term in the sequence is 57. I also know that my constant difference is going to be minus 6. Okay, remember the constant difference is your second term, take away your first term, or any term thereafter. So in order to use one of my formulas, I can use the first one up here. And I can say that S40 is going to be 40 divided by 2. 2 times my first term plus n minus 1, so 40 minus 1, and then times D, my constant difference. Then I can use my calculator to put those together. So inside my brackets, I've got 2 times 57 plus 39 times minus 6. And then I'm going to multiply that by 40 divided by 2, which is 20. And so I find out that the sum of my first 40 terms is going to be minus 2,400. The next example that we're going to do is find the sum of this series here, or find the sum of this sequence here, excuse me. But what we need to know is we're still looking for the sum, but this time we don't know what term number we're looking for. So the first thing that we need to know is figure out what term number this is in our sequence. So we can write down what we know. So we know that our nth term is 213. We know that our first term is 4, and we know that our constant difference is 11. Remember, constant difference is just the second term times the first term. So now we can actually use one of the formulas that we had before to find the nth term. And so if you recall, un is equal to u1 plus n minus 1 times d. What this is going to allow us to do is to find the term number for 213, which is going to allow us to find the sum. So I know that my nth term is 213. My first term is 4. I don't know what n is, but I do know what d is. Then I can rearrange and solve for n, and I'm going to get that n is equal to 20. This means that I'm looking for the sum of my 20 terms here, and then I can use either formula that I have up there. I'll do an example of number 2. So here I've got n over 2 times u1 plus un, and that's going to give me the sum of my 20 terms. When I evaluate that, I'm going to get 2,170 as the sum of my first 20 terms. Let's keep going and do a word problem here. Pop cans are stacked arithmetically in 8 rows. There are 44 cans in the bottom and 2 cans in the top. So let's think about our rows like our term numbers. So our first row is going to be our first term, and there are 44 cans here. Then I'm going to go all the way up to the top to row 8. So this is my U8, which is going to be 2 cans on top. So now the items that I know are my first term is 44. I know my 8th term is 2. And what I need to know is what the sum of those first 8 terms are, because that's going to tell me how many cans I would need to make this stack. So in order to do that, I can use my second formula, combining the first term and the nth term. In this case, I'm going to use the first term and the 8th term. So I've got n divided by 2, my first term plus my 8th term, which is going to give me the sum, which is 184. So that tells me that you would need 184 cans. Neat application there. Okay, one more example for an arithmetic series. Again, I'm just giving you information in different forms. Your job is to figure out the missing pieces and put it together. So here I know that my 10th term is 34. I know that the sum of my first 20 terms is 710. And the first thing that I'm asked to do is to find a formula for the nth term. So in order to find a formula for the nth term, I'm looking to fill in this equation right here. So I need to know my first term, and I also need to know what my constant difference is. So I'm going to start by using the fact that my 10th term is equal to 34 and that nth term expression. Because this is going to give me an expression for, in terms of U1 and D. So I've got 34 equals U1 plus 9D, which is fine. Okay, so I've got an equation here. Now I'm going to use the second piece of information that I was given to create another equation. So I know that the sum of the first 20 terms is equal to 20 over 2 times 2U1 plus 19D and minus 1. And I also know that it equals 710. So now I've got a second equation here. We'll expand a little bit further. 20U1 plus 190D. Here's my second equation. Now I've got 2 equations, 2 unknowns, and I can solve. So what I'm going to do here is just rearrange. You could use elimination as well if you wanted to. So U1 is equal to 34 plus 9D. And then I'm going to sub U1 into my second equation. So now I've got 710 equals 20 times 34 minus 9D plus 190D. And now I've got an equation that is only in terms of D. Simplifying and moving things around, I'm going to get that 10D is equal to 30, which means that D is going to be equal to 3. Now what I can do, go back over here, is I'm going to sub D equals 3 into, call this 3, into my expression for U1. So I've got U1 is 34 minus 9 times 3, which is going to tell me that U1 is equal to 7. So therefore, my formula for the nth term is going to be UN is equal to 7 plus n minus 1 times 3. Now it's a good thing that I figured that out because part B is going to ask me to determine the 25th term. So I can do that using my equation. 7 plus 25 minus 1, so 24 times 3. And this is going to give me my 25th term as 79. Now, moving on to geometric series, that is the sum of the terms of a geometric sequence. And so here's the equation that we have for the sum of the terms of a geometric sequence. And we're going to do some examples of using that formula. So the first one that we're going to do is find the first 15 terms of the geometric sequence. So that means I know that I'm looking for S15. I know my first term here, U1, is going to be minus 3. And I also need to know what R is. Remember, I can figure that out just by dividing two terms, second divided by the first, which is going to give me an R value of minus 5. My next step is going to be to substitute it into the equation. Minus 3 minus 5 to the n, which in this case is 15. Take away 1, all over minus 5 minus 1. Plugging that into your calculator, you are going to get a huge number, minus 1.53 times 10 to the 10, as your sum of the first 15 terms. Okay. Next example, just like the arithmetic series, now we're looking for the sum of this series here. And so we don't know what our nth term number is. So we can use the same approach by using our equation for the nth term of a geometric series. We can use that to find our term number for un, and then use that to find the sum. So the one thing that we do need to find is our R value here. So we can get that by dividing two successive numbers. So 729 divided by 2187, which is going to give me an R value of 1/3. Substituting in what I know into the expression for the general term, I've got 1 over 27, 2,187, 1/3, and then n minus 1, which I don't know, which is okay. When I rearrange here, so I'd have 1 divided by 27 divided by 2187, which is going to give me not a great number. It's a decimal times 10 to the minus 5. I'm then going to take the log of both sides, just like I did in the previous video, which is going to allow me to bring the n minus 1 down. What I'm going to get when I evaluate that log is 10 equals n minus 1, which is going to give me n equals 11. So divide, then take log of both sides, just like we solved those probability equations way back in our first block. So now that I know that my term number is 11, I can find the sum of my 11 terms by using one of the formulas above. 287, then I've got my R value to my n, minus 1, and then divide by my R value, take away 1. When you evaluate this, you are going to get approximately 3,280 as the sum of your 11 terms. Okay, one more example here, sort of an application type. A medical student starts treating a virus with 256 milligrams. This would be your first term, and continues to use 1/2 the dosage. This is telling you your R value. If she continues for 25 treatments, that is your number of terms, or your N. How many milligrams of the drug will she use in total? So you are looking for the sum of those 15 terms. All the information is given in the equation for you to plug directly in to the equation. So 256, 1/2 to the n minus 1, all over 1/2 minus 1. Evaluating that on your calculator is going to give you approximately 512 milligrams. So therefore, she would use 512 milligrams of the drug in total.